Assalamu alaikum. How are you, Shabab? This is the last video for subject of temperature measurement. It's to talk about how can we measure the temperature using the different technology. Now, this video is talking about a summary for the formula used in the previous devices that we already explained. As a coverage for this one, we already covered the unit conversion for the temperature measurement. Just a quick review for it. If I want to change from Celsius to Fahrenheit, just multiply by 9, divide by 5, and add 32. If you change from Celsius to Kelvin, add 273 by 0.15. And if you change from Fahrenheit to Rinken, degree, add 459.5. If you change from Kelvin to Reinken, multiply by 9 and divide by 5. And also we can utilize them, we can manipulate this formula in order to take the opposite or the reverse, or jumping from one to others. Also we talked already about the heat transfer amount required. We talked it and we covered it already. Just here for quick review for it. It is Q, which is mass, multiply the C, multiply the delta V. And we say that Q is the amount of raising or lowering the temperature, amount for raising, amount required, amount of heat required to raise or to decrease the temperature. And the mass C is the specific heat of the material, and you say it is the special properties of the material. Initial temperature and final temperature, the difference between them is multiplied by this specific heat material, which is a special property of material, and multiply the mass, which gives me the heat amount of required energy in order to increase or decrease the temperature. We talked about how can you utilize the expansion, the idea of expansion in the devices. This is the formula for it. And saying that we have here two way of the expansion, either volume or linear. Linear can be applicable for bimetallic strip. Like we say here, the final length, the final length, which is L2, equal the first length L1 multiply 1 plus the alpha in the delta T, the difference between the initial and final temperature. Also, the same thing can be applied also for the volume. Second volume or the final volume after the temperature increased, and the first volume in the initial temperature, all of them multiply. There is similarity between these two formulas. Just the change here is the ratio, the coefficients. And instead of linear coefficient, which is symbolized by alpha here, we symbolized it by beta here as volumetric expansion coefficient, multiplied by the difference in the temperature. And this is the two formula for that. If we try to solve example for this one, see here, it will calculate the length. It's saying that calculate the length and volume for 100 centimeter one side copper cube. It is cube. That means it has the same length for each side, and each side it has around 200 centimeter length. So the length is 200 centimeter. First length is 200 centimeter, and we can say also the first volume for it is 200 cube in centimeter cube. Now, at 20 degrees Celsius, so if the temperature is increased to 150, that means the difference between these 150 and 20 degree will be 130 degree. So just apply the same formula. Apply the first one and the second one also. The length of volume of copper. and we know this one is copper cube. That means we'll go to the coefficient of the linear expansion or volume expansion. I think it is here, above here or around here, the coefficient of copper. Just let me see if it available here. Resistance, coefficient degree Celsius material. No, this is the resistance. Anyway, should be found by a certain table or sequence. It's given, by the way. It should be given the exam. Anyway, so this is the coefficient for the linear expansion and the linear volumetric coefficient for the volumetric expansion coefficient for the copper. These are copper. Just only multiply them. This is the 200, which is the first length. Multiply this 1 plus the coefficient, linear coefficient of the copper, multiply and the difference between them in order to find the length. He transferred it from Fahrenheit. You see here is transferred from it should be transferred from degree Celsius to Fahrenheit, because this one is given by Fahrenheit as expansion coefficient length per Fahrenheit degree. So multiply them by this Fahrenheit, by the degree Celsius, then convert it to Fahrenheit. Of course, maybe you notice here there is 32 plus minus, they are cancelling each other. That's why it's disappear. The same thing for volume. Just convert to Fahrenheit, multiply instead of the alpha, multiply by the beta of the copper. Also, here is given as the volume change per Fahrenheit degree. And see here, this is the volume size. Multiply the result, it will give me this, the change. This is the new change for them. Okay. This also the ideal law of gases. The ideal laws of gases. Or can see the law of ideal gases. Here is applied for this type that's filled by the gases with the gas by the gas expansion temperature thermometers. This law is applied for them. It's saying that the initial pressure multiply the initial volume divide by the initial time will give you the same ratio for the second or the final one. If we say V1 equal V2, in this case the relation between B1 over T1 equal the relation of B2 over T2. Just find one of them, just find three of them, you will find the fourth. And this is the utilization of using this ideal law or gases or law for ideal gases. We already talked also about the resistance change, RTD. This is the formula utilized in measuring this or in finding the values of the temperature according to the change in the resistance. It's saying that the resistance for the first temperature multiply 1 plus the coefficient of the delta T. Also, maybe we notice here there is similarity between this formula and also the formula for the length expansion and the volume expansion. Just the change here is the coefficients. And instead of mentioning the length or volume, here we'll put here resistance. Resistance for the initial temperature, it will give me the resistance for the final temperature. All of them multiply by these coefficients. So there is some similarity between them in order to find these values. As example here, what is the resistance of platinum resistor at 250 degrees Celsius? If its resistance at 20 is 1050 ohm. So this is the first temperature, the resistance for the first temperature, and this is the second temperature. So he asked me to find the resistance, which is the second R2 here. Sorry, I'm using the mouse, not the touch screen. That's why the right is very bad, little bit. But okay, let's pass it. If now we have R2, we have R1, I mean, and T1 and T2. يعني you can just adjust it here. The writing by the mouse is a little bit difficult. Anyway, we have T1 and R1 and T2, and the coefficient should be taken from the table here. And it's mentioned that resistance of platinum. Here the resistance of platinum, which is saying that per degree Celsius. How much per degree Celsius? So go there and this degree Celsius, multiply in the difference in the temperature between them, then it will show you how much the change in the resistance. So just multiply the first resistance to all of them and give me the final resistance added to them. So by the end of this formula, there are also other formula mentioned in the box, but we will not include it in the material or the covering or the material coverage of this semester. So only these formula are included in the exam. The other ones that we don't explain it here is not covered in the exam, and it will not be as a part of the final exam. Thank you, gentlemen, for watching all this video, and we will see you inshallah next semester inshallah, and good health and good knowledge also. Thank you, gentlemen, and see you inshallah next year. Assalamu alaikum.